Good afternoon, Edmonton Christian, and welcome to the final lesson of Math 20-1. Today we have linear and quadratic systems and inequalities, lesson number 7, solving quadratic inequalities in one variable by sign analysis. I will now pass the mic on to my associate, the one, the only. She's on all them posters. Miss Carlson!
Good session. Okay, so today, lesson number 7. So when we are doing sign analysis, we're doing things kind of similar to case analysis. Personally, I find sign analysis a little bit easier, but not everyone will find it easier. Okay, so if you look here, we have x squared plus 2x minus 8, and we have a picture of it right there. So if we were to solve this, we would know that we would have to factor this first. So we'd get x plus 4 and x minus 2, which means that our x-intercepts are -2 or -4 and 2. And so if we look at this, our x-intercepts kind of divide our graph into 3 intervals. Right? So we have one where x is less than -4, where x is greater than -4, greater than -4, and less than 2, and one where x is greater than 2. Okay? So then we can look at this and we say, okay, when x is less than -4, the function is positive, and the middle one, when it's between -4 and 2, it's negative, and when x is greater than 2, it's positive. Okay? So, if we are doing this, we can look at a chart we have down here, and it says, okay, we have the 3 intervals, less than -4, between -4 and 2, and greater than 2. And we can use test points in these intervals to figure out whether or not the graph is positive or negative in this section. So if we need a test point less than -4, maybe use -5. Between -4 and 2, I would test 0. Okay, keep our life easy. And for x greater than 2, I'm going to test 3. Okay? So we go -5 squared plus 2 times -5 minus 8 gives us 7. So we know that this part of the graph is positive. When we test 0, we go, okay, 0 squared plus 2 times 0 minus 8 gives us -8. So we know this middle portion is negative. Okay? And then we say, okay, if we test 3, we can go 3 squared plus 2 times 3 minus 8. So we get 9 plus 6 minus 8 gives us 7. So we also find out this interval is positive. So exactly, there's 3 different ways that we can figure this out now. When we look at this, if we see that this is positive, we know that our graph is going to have this shape, right? And then we find the x-intercepts and we say, okay, we know, because we've looked at these graphs before, that if it's positive, this is going to be the part greater than 0. And this is going to be the part less than 0. If it's a negative x squared, just a second, Josh. We know exactly that the middle part will be the positive and the ends will be the negative. Yes?
Are the positives always going to be the same number? Like, are they both going to be 7 or 9 or 2 kind of a thing?
No, the reason that they're both the same number is because we just chose one directly to the left of 4 and directly to the right of 2. So because of symmetry, we get the same number. Okay? So we know that our graph is like this because of the equation. We have a picture of the graph, so we say, okay, well, we know that this is the positive part, and this is the negative part.
So then why did we have to do 4?
So if you're not given any of this information, you can do it like this.
If you're not given the graph.
Yeah, exactly.
So why wouldn't you just put it in your calculator?
Because it'd be a long answer question.
Oh.
And you'd get a mark for the graph. or for the chart. Okay? And so we'd say, okay, the solution is greater than 0 when x is less than 4, negative 4, and greater than 2, because we can see, okay, it's positive here and here, so that fits with this. And then we say the solution is less than 0 when it's between negative 4 and 2. And we know that because we say, okay, well, this is negative here, and this means negative right here. Yeah? No, they're going to specify.
I'm guessing you've seen one of those.
No, you'll have to know how to do both.
Is it hard?
It's not bad.
Is it harder than the last one? Because I thought the last one was easy, but one more.
I think everyone here can get 100% on the multiple choice, for sure.
Yeah, and then you run out of time on that. I think you only get a 72.
Okay, so if we flip 2 pages forward, so we're skipping page 544.
No one loves 544?
Okay, so so in this question they're asking us to solve the inequality using test intervals. So the first thing we want to do is, of course, graph it, because we want to be able to solve this even before we do anything else. So 8x minus x squared, like that. Okay, and so on your test, like, I'll be looking for a picture of the graph. I want to actually see a small sketch of it. No. Yeah, my windows are quite big. Okay? So we know that with these sort of questions, we're going to need our x-intercepts. So let's find that right away. So we say, okay, the 1 is 0. Oh, not 8. 0. And then we can find our other ones. So we go second trace, intersect, all the way over to the other one. Yeah. We go enter, enter, enter. And we get that this one is 8. Okay? So they're asking for where is the inequality less than 0? So we can look at it and we say right there and there, less than 0. So we say when x is less than or equal to 0, and when x is greater than or equal to 8. Okay? So if this was a multiple choice question, we'd be on to question number 2.
Hey, that's like a box.
Okay? So, but because it's a long answer and they ask us to use test intervals, we go like this. We say, okay, we're going to draw a little chart. So we say intervals. So remember we said we have 3 intervals to our graph. So we have one here, and one here. So we have x is less than or equal to 0. X is between 0 and 8. So it's greater than 0 and less than 8. And x is greater than 8. Okay? And so we know that, okay, if we were to factor this, we have 8x minus x squared like this. Our factors would be x and 8 minus x, right? So we want to have what the sign would be when we multiply our factors together. Yes? Yes. Yeah, just normal. We found our GCF. Okay? So remember when x is a GCF, we include x as one of our factors, right? That's how we got that 0 was our x-intercept. And so we need to find a test point for each of these intervals. So in this one, I would test -1. In the middle one, I would test maybe +1. And then for x greater than 8, I would test 10, because 10 is really easy to work with, but you could test 9 if you want. You could? Okay? And then so I go, well, 8 times negative 1 minus negative 1 squared gives us negative 8. Ooh, that looks like a positive. Negative 8 minus 1, right? Is equal to negative 9. So we say this is negative, which makes sense because we look at our graph and we say, yep, that's true, that's negative. It should always match up with your graph. If it doesn't, check your math and make sure that you graphed it correctly.
Which means you can't wheel the calculator.
Mm-hmm. Yes? Yeah. So because we have it there, I would use it straight across, right? Because you always want to use this to dictate the equal to. Okay? So, Josh. So we're going to test positive 1 now. So we go 8 minus 1 gives us 7. So here we have a nice positive section, which matches with our graph there, so that's good. And then when we test 10, we go like this. Minus 10 squared gives us 80 minus 100. So we get negative 20.
Hey, just like that.
Just like that. And it matches what we've already found. So we know that we're on the right track. So then you just have to show, okay, that solution is when x is less than or equal to 0, or x is greater than or equal to 8. Okay, and that matches with what we have there. So everything's good. No, I have other classes that day. Okay, so is that a question, Aaron, or a stretch? Yep. Okay, so if you look, guys. Mm-hmm. Yeah. So in our original right here, that always tells us. So you always want it to be the same as this one. If it's just greater than, then your answer will be a just greater than. Because it's a less than and equal to, our answers are going to have those equal tos. Okay? Okay, so here they have all the steps for it.
Yeah, I love this page.
So
Hey, is this like
This out, put it on.
it is
Whoa!
quality study sheet material.
Say that
Are you allowed to do
again.
that? Are you allowed to cut it? Can I cut this out and paste it?
I wouldn't.
Yeah, I would cut a hole in my book.
Okay? So what I want you guys to do is before step 1, right, step, I don't know, like 0 or 1A or something.
4.5.
Step 0.5, we can call it that.
Step infinity.
And I want you to write, graph it, right? Because first you want to graph it and find your answer. Then you want to do all the steps. Okay, so first we need to factor it, and then determine the zeros. And what's another word for zeros?
X-Intercepts.
Awesome.
There's another word for it still.
What's the other one?
Roots.
Roots. Awesome. Okay, so focus. So then step 3 is to use the sign chart. So the chart up here is called the test interval chart. The sign chart is a little bit bigger. It looks like this. And we're going to be doing an example with it.
Is it pretty much the same thing?
But it's pretty much the same thing. Okay? And I would say definitely learn how to use the sign chart.
Will you have a choice between using like the
Case analysis or sign analysis.
test?
They'll ask for the sign chart. They'll even give you the chart to fill out.
Oh.
Okay? Okay? And then they have it as the last step to look at the original inequality and look for the solution that matches with it. I'll explain it. Okay? But I would say, okay. So I would say As step 4, they have looking at the original inequality and figure out whether you're looking for positive or negatives. But I would say that would be one of your first steps, right? Because you're looking for that when you first graph it. So even write a note like, this is the graphing step. You should already know this. Okay? Because if you figured out your solution based on your graph, you already know whether or not you're looking for the positives or the negatives. Right? Okay, so if we flip to the page, we're going to do a good example with using the sign chart. So we'll explain the chart as we use it. That's just a good example. There's no really bad example. Okay, so they ask us to factor the expression. So Justin, what's the first thing we do when we're factoring something? Awesome. So our GCF here is -3. 6 doesn't go into -39. So 2x squared plus 13x plus 6. And so this is still type 2 factoring now, so we need two things that add to 13 and multiply to 12. Awesome. Okay, so we get 2x squared plus 12x plus 1 plus 6. And so we still have to do our grouping and stuff, so we know that our first two, or the term we have in our first two, is 2x. So we get x plus 6, and we get a 1, and leaving us with an x plus 6. So our final factored form is -3 multiplied by 2x plus 1 multiplied by x plus 6. Okay? Okay, so we actually have 3 factors here. We have this one, and the -3 is considered a factor, right? It's our greatest common factor.
Hey, GCF.
Exactly. So what I would like everyone to do in their notes is you'll notice that here they have a plus 18. Scratch that out and change it to a -18 so it matches with part A.
Man, this book's just full of typos.
It's a new course.
People are stupid as practice.
Okay? So we know the first thing we want to do is factor, or not factor this, we already did that. We want to graph this. So we go -6x squared minus 39x minus 18. Graph it. Something that looks like that.
Would graph be different if we GCF it?
Yeah, because it'll change like the stretch of everything, right? So you have to keep that -3 in there. So when I'm graphing this, I always just put the original back in rather than this, because if I made a mistake here, I'll catch it when I put the original in, right? Okay, so we want to find our x-intercept, so we go enter, 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 -½
That's a name.
second trace intercept, enter, 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 -6. And then we can look at this and we say, okay, that's perfect because that matches with this and this. Okay? So when they're asking for the inequality less than or equal to 0, we know it's going to be this part and this part of the graph. So you can write x is less than or equal to -6, and x is greater than or equal to -1/2, like this. So we know that's our answer. If this was multiple choice, we'd be done. But it's not, so you have to learn how to do this.
Where does it say it's not?
Okay, so
Wait, Steve.
when you do these, the first column is going to be all the factors. So we have, okay, so remember, -3 is one of our factors. Then we have 2x plus 1 and x plus 6. Okay, so when we're setting up our chart, Justin, when we're setting up our chart, we want to put all of our factors down the one side. So we have the -3, the 2x plus 1, the x plus 6, and then we have them all together. So we have the product. Okay. Product. Yep. And on the test, we'll give these boxes to you. We'll give you a chart. Don't even have to draw it. Okay? They might give you the very top row. Okay? So, guys, focus. Okay, so we know that our graph has 3 intervals, like this. It's the same temperature it always is. Okay, so we have our 3 intervals. So we have when x is less than -6. But when we're doing these sign analysis charts, we also include our x-intercepts. Okay, so you have less than -6, and then we have -6. The next one will be x is between -6 and 1/2. Okay, then we have -1/2 because we treat our intercepts as separate things. Product. So when we multiply them all together. Okay? Okay, and then for the last one, we're going to have x is greater than -1/2. Okay? So, from our 3 intervals. So we have when x is less than 6 here, then we have the x-intercept at -6. Then we have the space in between, so between -6 and -1/2. Then we have that x-intercept, and then we have when x is greater than -1/2. Okay? So now we have to fill out the signs of everything in this chart. Okay? So there's some things we can fill out right away. So we can fill out, for example, we know that at our x-intercepts, -6 is going to make x plus 6 equal to 0. And we can make this one a 0 as well, because we know -1/2 multiplied by 2 plus 1 will give us 0. Well, this is our x. Okay? We also know that for our -3, we're not actually multiplying it by any x's, so all of these are going to be negative. Okay? So when we're doing this, what we have here is our 3 factors, and we're saying, okay, what is it when we multiply it by something, or when we have x is less than -6? What is it when we have x is equal to 6? What is it when we have x between the 2? What is it when we have x is -1/2? And what is it when x is greater than -1/2? Okay, so with -3, there's no x in that factor, so we know it's going to be negative all the way across. Okay? For the 2x plus 1, we say, okay, x is less than -6, so maybe we'll say, okay, plus -7. So we can go 2 times -7 plus 1 gives us -14 plus 1, -13. So we're going to get a negative. Okay? And then we can go, okay, well, -7 plus 6 gives us -1. So this is also a negative. Then for the product part, we get to say, okay, -3 multiplied by 2x plus 1 multiplied by x plus 6. So you go, well, that's a negative multiplied by a negative, so it gives us a positive, multiplied by another negative. So what's our product, Josh?
A negative.
You got it. Okay? And then we could even look at our original chart and say, yeah, we're looking for negative answers. That fits with what we have in our chart. Life is good.
Dolce Vita.
Okay? So it's just a way of showing it and organizing your work. Just like case analysis is one way of showing it, algebraically, this is the other. Okay, so we go 2 times -6 plus 1 gives us -12 plus 1, so it's a negative. So we have a negative multiplied by a negative multiplied by 0. So we know wherever we have 0 as one of our answers, here and here,
All the rest are 0.
the result is going to be 0, exactly.
I want to go ahead between them to 0 too.
This part here.
No,
So this one will give us an answer because it'll be -1/2 plus 6. And it'll give us a positive answer, but it doesn't matter because we're multiplying it by 0.
okay, so it's 0.
Okay? So to test something that's between -1/2 and -6, I'd maybe test -1. So we go 2 times -1 plus 1 gives us a negative. And then we can say, okay, well, -1 plus 6 gives us a positive. So we have a negative multiplied by a negative, which gives us a positive, multiplied by another positive, gives us a positive. And then we say, okay, well, that fits with what we have in our chart. So for this one here, yeah, exactly. So for the bottom line, you're going to want to take this, multiply it by that, multiply it by that to give us that. So for example, in this middle one, we'd have a negative multiplied by a positive, multiplied by a positive. This one, we'd have a negative multiplied by a negative. Like that. Okay? And then so for our last one, if we look at our chart, which part?
Negative times a positive times a positive, what makes you use negative?
Oh. Good catch, Justin. It's a negative from here times a negative times a positive. Okay? So based on our graph, what are we expecting for our answer here with the product?
0.
We have
Negative.
awesome. So you can even fill out a lot of the chart before you even use the test values. So we need a test value greater than -1/2. So you could test 0 or 1 is a nice one. So we know we have 2 times 0 plus 1 gives us a positive. Then we have 1 plus 6 gives us a positive. And so we know that we have a negative multiplied by a positive, multiplied by a positive, gives us a negative.
Well,
Okay?
class B thing, totally.
Okay? And then we just get to look at it and say, okay, we're looking for something less than 0. So our answer is here and here. So we say, okay, when x is less than or equal to -6. And because it's equal to 0, we know we also include this part. And we know when x is greater than or equal to -1/2, which matches with what we found right here. The question is it? Don't have to do it.
Means that it enriches your understanding.
Yeah, so the enrichment is kind of like above and beyond what the curriculum asks for. I'm not assigning it.
It's greater level.
Okay, so for the homework today,
Oh, you're not recording.
Yeah, I am.
No,
Or not, you cancel it.
Nope.
She faked
Oh, can I
it.
do the sign off?
No. Okay, so for homework, 1 to 10, omit number 9. Okay? And that is the last lesson for 20-1.
You have to say, this is Miss Carlson signing off.
This is Miss Carlson signing off.
If you're listening to this,